Hey guys, today we're going to still be working on fractions, but we're going to be working on fractions that are greater than 1. So that means that they'll either be equal to 1 or greater than 1, sorry. Our objective is to express whole number fractions on the number line when the unit interval is 1. So let's start by looking at this first one. It's important to remember that one shape equals one whole, okay? This is one shape. All of it is shaded in, so it's equal to one whole. Looking at this next shape, this next rectangle here, how many pieces is it broken into? 1, 2, oops. 1, 2, 3 pieces. So our denominator is 3. How many pieces are shaded? 1, 2, 3 pieces are shaded. So our numerator is 3. Looking at our next one, it's important to remember that you only count the number of pieces in one whole when you're figuring out the denominator. So how many pieces are in one whole? 1, 2. So our denominator is going to be 2. But how many pieces are shaded? Well, more than one whole piece is shaded. So it's 1, 2, 3. 3 pieces are shaded. Another way to write this would be how much is this first object worth? Well, it's worth one whole. So that's one whole. How much is this one worth? Well, it's worth 1/2. So 3/2 is the same as 1 1/2. How many pieces is one whole broken into for this one? Well, it's not broken into any pieces, so it's over 1. How many whole pieces do we have? 1, 2, 3. 3 whole pieces are shaded. 3/1, which is also equal to 3 whole. 3/1 equals 3. Let's look at the next one. How many pieces do we have? That's how we figure out our denominator, is how many pieces one whole is cut into. 1, 2, 3, 4. So our denominator is 4. How many of those pieces are shaded? 1, 2, 3, 4. So our numerator is 4. 4/4 equals what? Well, it equals one whole. We know that any number over itself is one whole. Next one. How many pieces are in one whole? That's going to be our denominator. 1, 2. That's our denominator. How many pieces are shaded? 1, 2, 3, 4. 4 out of 2 pieces are shaded, which is also how many total are shaded? That would be 2 whole pieces. All right, looking at this one whole. How many pieces is that broken into? It's just one piece. How many whole pieces are shaded? 1, 2, 3, 4. That's 4/1, and 4/1 is equal to 4. Next one. How many pieces is one whole broken into? 1, 2, 3, 4, 5, 6. So our denominator is 6. How many of those pieces are shaded? Well, we can see that all 6 of them are shaded. So 6/6 also equals one whole. Next one. How many pieces is one whole broken into? 3. How many are shaded? 1, 2, 3, 4, 5, 6. 6 out of 3 are shaded. Next one. 1, 2, 3, 4, 5. Oh, sorry, I did that incorrectly. Ignore what I just did. Okay, so how many pieces is this first whole broken into? It's just one whole piece. How many holes do we have? 1, 2, 3, 4, 5, 6. So that's going to be 6/1, which equals 6 holes. The important thing to remember is you only count the number of pieces in one whole for your denominator. So this one whole has 3 pieces, so 3 is our denominator. This one whole has 2 pieces, so 2 is our denominator. This one whole has 1 piece, so 1 is our denominator. One whole has 4 pieces, 4 is our denominator. One whole has 2 pieces, 2 is our denominator. You're not counting the total of number of pieces and of pieces broken into all of the holes. You're just counting the pieces in one whole. All right, let's go on to the number line next. Okay, so on the previous page, we learned that 3, oops, let me get my pencil up here. Sorry, y'all. Okay, so on the previous page, we learned that 3 over 1 is equal to 3. Any number over 1 is equal to that whole number. It's saying one whole of that. So 0 would be 0 over 1. 1 would be 1 over 1. 2 would be 2 over 1. So these are the fractions that represent these whole numbers. What fraction represents the whole number of 3? Well, 3 over 1. What fraction represents the whole number of 4? 4 over 1. What whole number represents the fraction of 5? 5 over 1. And what whole number represents the fraction of 6? 6 over 1. The second number line is very similar, only you have to fill in both the whole numbers and the fraction that represents the whole number. So if we have 10 over 1 up here, the bottom is just going to be the number 10. 11 over 1 for the fraction, it's just 11. Here they want us to give the fractional amount for 12 wholes. So it's going to be 12 over 1. 13 wholes, 13 over 1. 14 over 1 is equal to 14. 15 is equal to 15 over 1. 16 is equal to 16 over 1. And you can see the pattern. 10 over 1, 11 over 1, 12 over 1, 13 over 1, 14 over 1, 15 over 1, 16 over 1, 10, 11, 12, 13, 14, 15, 16. You can see the pattern. I'm going to go over number 3 with you. You will not have to do one like this, but I want you to know what it means, what it's talking about. So it says, explain the difference between these two fractions with words and pictures. So 2 over 1. We have one whole, but 2 of 1 wholes are shaded. So that represents 2 over 1 because it's 2 wholes. 2 over 2. So I have 2 pieces inside of 1 whole, and both of those pieces are shaded. That is the difference. The denominator is the number of pieces in 1 whole. This one, the number of pieces in 1 whole is 1. This one, the number of pieces in 1 whole is 2. That is the difference. Hopefully you guys understand what we're doing here. If you have any questions, let me know and I will help you. But it's just important. The most important thing to remember is when you're figuring out the denominator, you're only counting the number of pieces in 1 whole for your denominator. But then the shading, you count the pieces in all of the wholes. So if you have any questions, let me know.